Okay, so we left off on Friday, and we ran out of time. So I just wanted to kind of go over it a little bit quickly, covering the group by stuff. So in Pandas, we have the ability to calculate summaries, such as the means or the median, the min, the max, whatever. Any of these kind of summary values, standard deviation, stuff like that. For the data frame, but also for kind of groups within the data frame. And so you can specify groups using one of the variables. So for example, in this data frame, I've got a couple keys, or a couple columns. I call them key 1 and key 2, but they could really be any column. And here it's a categorical column, and I've got, category A and B and 1 and 2 and things like that. And so I can just say, hey, you know what, take this data frame, okay, and we're going to select data 1, and we're going to group by key 1, okay? And what that will do is it will create kind of a grouped by series. So data 1 is a series, and then we're going to say group by. So you can't do anything with that directly, but once you have that grouped, and again, this object, I can always chain the methods. So I don't actually have to do grouped equals this thing. I could just kind of do data frame, select data 1, group by key 1, and then just chain the mean method. And this will calculate the mean for group A and group B. So it's going to say, B is 12 and 8, and the mean of 12 and 8 is 10, and group A is 5, 11, and 9, so that's, sums up to 25 divided by 3, you get a mean of 8.33, okay? If you don't specify, so here I said select data 1, if you don't, I can just say, hey, group by key 1, and then calculate the mean, and it's going to just go ahead and do it for any kind of numeric variable. So it's going to say, all right, for group A, this is the mean of, numeric column data 1, mean of numeric column data 2, so on and so forth. Okay. You can also group by multiple keys. So you can group by key 1 and then by key 2, and so it will do A1, A2, B1, and B2. And here, because we have A1 appear twice, that will get factored into A1, but everything else, the mean of A2 is just 11, and B1 is 12, and B2 is 8. But the mean of A1 for data 1 is 5 and 9, and we get 7.0. So all of those things, I think we have that. If you have this thing, this itself has a multi-level index. And so you can unstack it, right? So if you have a hierarchical index, you can also unstack that, and then the 1 and the 2 being kind of your second key will get unstacked into columns. So you have key 1 is AB and key 2 is 1, 2. So these are just kind of different different things that can be done. You can also take the data in a data frame and group by a series that is not in the data frame, okay? As long as the second series is the correct length. So in our case, we have 5 rows here, 5 rows in our data frame. So I could take a second series, and here I just kind of have a series Ohio, California, California, Ohio, Ohio. So I've got 5 entries over there. And I can take that second series and I can group by that. You can here I have another series of years 2005 and 2006 kind of jumbled up in there. And I could say, hey, group by these 2 series, group by states and years. And even though they are not necessarily part of this data frame, you can also use this other variable or this other series as a way to form groups. Okay, which is handy because sometimes you've got data in one data frame, and you can just extract a series from one data frame, and you can use that to kind of do an operation with another series in another data frame. So as long as they're of the right length, okay? If they're not of the right length, then it doesn't know what to do. Let's see what else. Okay, so all of these examples I've been doing .mean, okay? There's a whole bunch of other functions. So .size will just give you a count. There's like median, there's min, max, things like that. When you do a group by operation, it creates kind of this iterable, almost like a dictionary. Okay, so it creates kind of I guess it creates a series of tuples. The tuples contain the name of the group and then the data in that group. All right. So here, if I do data frame group by key 1, okay, it creates a tuple containing the name and the group. And so here, the name is A, and so I'm just saying print out the name, print a dash, print out the group, and you'll see the group itself is basically a data frame where we've subset it to key 1 equals it to A, right? And so you can see when you say group by, and you do something like group by key 1, and then you select the size, basically you're working with like this smaller data frame. And so with that, you can do something like, what is the mean of data 1 and what's the mean of data 2, or something like that, okay? And so I have this iterate over, whatever groups were created by grouping by key 1. So first we do name A, here's the group data, here's kind of the calculations using the group and data1.mean, and so on and so forth. And then it goes to the second one. We have name is B, the group is this data, then we're going to calculate the mean of data 1 and the mean of data 2. Same kind of thing. Here I've grouped by key 2, and that works. Same kind of way. So these are just examples of the group by operation. It's actually going to be probably one of the more frequent operators that you're going to use. It's very, very handy within kind of working with a pandas data frame. You frequently have different groups, and you frequently want to calculate averages or things based on particular groups within your data. So really familiarize yourself with the grouping, and then the other part from Friday's lecture is the pivoting. And I would say both of those things are pretty good to be familiar with. And like everything else in the class, you're going to gain competency by just frequent practice. Okay, so I give you a little bit in your homework, and a little bit from like data camp and things like that. But really, I encourage you to kind of, take some kind of data set that interests you and just try to work with it and manipulate it and see how much you can do. You might whenever you start something new, you might feel more comfortable falling back on something that you're more familiar with, maybe R. Maybe you're even more comfortable with using something like Excel or whatever, right? And these are all very kind of powerful tools that can do lots of great stuff. But if you want to gain proficiency in Python, you kind of have to force yourself to use it. Right? It's like if you want to learn a foreign language, okay, and you go to a new, let's say you want to learn Spanish, and you say, okay, well, I'm going to go, visit Mexico for a few weeks. But if you travel with, some English-speaking friends, and you just only speak English the entire time, you're not going to learn the foreign language. So you have to kind of force yourself to use the foreign language. You got to force yourself to use Python in situations where you're not comfortable with it. and that, that will stretch you and you'll get better. Okay, let's go ahead and switch over to lecture 6.1, and let me clear all of my outputs. So this should be up on the GitHub repository. And here I want to just introduce some plotting stuff with Matplotlib, okay? And Pandas actually implements a lot of kind of Matplotlib things. So I don't get to it till towards the end of our lecture, but I highly encourage you on your own to kind of explore some of the plotting features within Pandas. So Pandas kind of uses Matplotlib to do a lot of kind of these plots, but yeah, it's handy here. All right, so we import NumPy, we import Pandas. NumPy is NP, Pandas is PD, and from Matplotlib, kind of the set of functions are under kind of this subgroup called pyplot, and so we'll import that as PLT, and that again, that is the convention. So people are kind of accustomed to saying that, but anytime you want to look up help, you'll look up like Matplotlib pyplot for whatever it is that you're trying to do. Okay, so first, we'll just create a very, very simple plot, and we're going to say, hey, let's create an array of 0 to 2 pi, 500 values, okay? And so we're going to get that. That's going to be an array of x, our array called x. And then we're going to say, hey, let's calculate the sign of all of these values, okay? And that will form our array y. And so let's say we want to plot x versus y, right? And so we just want to see a sine curve going from 0 to 2 pi. So what we do is we call plt.plot, okay? And in order to kind of get the plot to show, you have to call plt.show, okay? So it's kind of like calling print, but in this case, it's to kind of get the plots to appear. One thing is that in Jupyter, even if you don't call plt.show, Jupyter has this habit of kind of printing or outputting, showing you whatever object is that was kind of created at the end. Okay, as long as you're not like doing an assignment operation, Jupyter will often kind of show it. But I would say it's good practice to call plt.show. Matplotlib.pyplot.show. There's also other functions that you can run between after creating the plot and before showing it. That's going to kind of modify the plot. So things like adding the title and changing the x limits. So the default is to kind of add a little bit of padding on the left and right hand side. And so, but in our case, because our plot goes from 0 to 2 pi, we're going to say, hey, I don't want to see the padding on the left and right. I want my x limits to be from 0 to 2. And so I can run that, and there you go. Exactly as we would expect, right? Plot of sine of x. So the default, when you call plt.plot, technically, this is what we are plotting is not the sine curve itself. It is 500 locations of x. Okay, so there's technically 500 little locations between 0 and 2 pi, and we've calculated the sine of x of those 500 locations. And the truth is that what is being plotted is there's, I guess, 500 little line segments that have connected, or maybe 499 little line segments that have connected those 500 locations. Because there's so many of them, it looks like a smooth curve, but computers don't really plot smooth curves. It just has a whole bunch of little locations that we've connected with these tiny little line segments. Okay, here's just another kind of thing. Here I'm going to just take 6 points from, or I guess 5 points, and here I'm going to just have some 5 random integers between 0 and 9, and then here I'm going to do plt.plot, and so here this will kind of make the what do you call it? The nature of having the dots kind of connected be a little bit more apparent. Okay, when you run this, you might get slightly different things because it's a random call. So the random locations will probably be different. And so, this looks like there's only 1, 2, 3, 4, but there's actually a plot right here, point at 2, 5, and it's just exactly in the middle between 1, 1 and 3, 9. Okay, so it's plotting 0, 5, 1, 1, 2, 5, which is right here, 3, 9, and 4, 1, and it just kind of connects all of those line segments. If you don't want the lines to be all connected, instead of doing plt.plot, you can do plt.scatter. plt.scatter x and y, and then do show, and there you go. You get the exact same dots, but they're not connected with lines. All right, let me go ahead and give you your first view quiz answer. Question 1 is D. Okay, sometimes you want to plot multiple lines on the same graph. You can do that. So here I'm going to create x. That's going to be 0 to 2 pi, 500 values. And then we're going to add y is sine of x, z is tangent of x, w will be cosine of x. Okay, and if I want to show this, okay, I can do plt.plot xy in blue, plt.plot xz in red, and I'll call show. Now, what happened here, right? So tangent of x technically goes off to positive infinity and negative infinity, right? And so the blue, which is sine of x, goes from 0 to 1, but it looks like it's a flat line, okay? But it's the sine curve. It's just on the scale, it's kind of been muted out. And actually, tangent of x doesn't go to 1. We've calculated at these 500 locations. I don't think I have exactly pi over 2 as one of these locations, and so I don't have exactly positive infinity or negative infinity, but just something pretty close to it. And so I'm getting something like 300 and negative 300, and just kind of so it doesn't know. It's just calculating this thing and saying like, oh, okay, not at 90 degrees, but like 89.5 degrees, you're at like tangent is 300 or something, right? Something like that. Okay, but here if I do sine of x and cosine of x, this is probably more familiar. And so when you do plt.plot and you have these different things, matplotlib kind of automatically adjusts the axes. It says, all right, this blue line goes from 0 to 2 pi, and ranges from positive 1 to negative 1. So it kind of frames it there. Same thing with the cosine in orange here. And you can see, again, the default is to add a little bit of padding to the left and right hand side. But if you want to change your x limits, you want to change your y limits, you can do that. So so here, if we want to plot x and y, so that will be sine of x. There are things like you can change the title, you can change the x label, you can change the y label, and so these are all of the kind of different options here. I always forget what the thing is. It's because in my brain, like a lot of these things have underscores, and I always forget. And like in R, you have like Y lab or something instead of Y label. So I always kind of forget these things. So I always end up just going online and I type in. I keep using Edge, but let's go to. But the default there is like Bing. But anyway, so I'll do something like matplotlib change Y label, okay, and then you go, oh, okay, yeah, pyplot.y label, right? So generally, there's lots of different things. Your most reliable source will be the official documentation. Okay, matplotlib.org will have kind of the official documentation, and all of these things, the API reference, how do you interact with the thing, that will have all of the function names. So, okay, so that's xlabel. All right, here if you want to change your x limits, it's xlim, and you put in kind of your min and your max. So here we're going to go from 0 to 2 pi. And then there's axis. Axis, you can kind of set the aspect ratio. And so here, the default is to kind of fill in from, here I'm going from 0 to 2 pi, which is, why didn't this work? Did I do something wrong here? Okay. 0 to 2 pi, but then if I do axis equals, the x limits get changed. Okay. I'll have to figure out what's going on there. But here it tries to put the x-axis on the same scale. So if you were to plot a circle, it will look like a circle, right? If I try to plot a circle here, it's not going to look like a circle. Yeah, question?
But if you move the x limit after axis equals.
Let's see. Let's see if that makes... Oh, yeah, that works. That works. Okay. So I guess the order in which you call all of these things makes a difference. Okay. So we'll put axis equal, and then we'll change the x limits after we call axis equal. Okay. But yeah, axis equal, we'll make sure when you plot something like x squared plus y squared equals 1, I mean, you got to change it to square root of whatever. It'll look like a circle. Okay. Versus, if you don't have axis equals, it doesn't look like a circle. Okay, there are options when you create like a scatter plot. So the default is little dots, and the default kind of the first color is this, I don't know, whatever color this blue is, okay? But you can kind of change the colors, you can change the size of the dot, you can change what your marker looks like, okay? So here, x and y is sine, and x and w is cosine. And I'm just looking at, we're just going to look at a small section from 0 to 0.2, okay? And so here I said we want diamonds in maroon, and I want hexagons in dark slate gray, okay? There are named colors here. You have single letter shortcuts for colors as well. So you can do things like blue, green, red, okay? These are kind of your single letter shortcuts, and these are, I think, probably simple enough for you to remember, but, blue, green, and red, those are probably gonna get the job done for a lot of cases. But you can also do cyan, magenta, yellow, and black CMYK, which is kind of terms borrowed from like the printing industry, because those are the colors that you get when you like your printing. And then white, but we often don't try to produce lines in white because the background is generally white, and so it's, you're not going to be able to see it. Okay, but blue, green, and red, and that looks like that. Okay, so so that's no surprise. There are a whole bunch of named colors, and let me open that up. Okay, so list of named colors. So you have, okay, so these are your single letter colors. Then you have Tableau based colors, and then you have all of these things, which I guess are CSS colors. So, and I have no idea, right? So this is dark goldenrod, corn silk, gold, lemon chiffon. Okay. This is, I challenge anybody to, if you cover up the names, name this. Would you know this was tomato? Probably not, right? But anyway, you have these options. My general recommendation: no more than 7 colors on a plot. That's kind of once you have more than that, can you imagine a key where it's like these dots for coral represent this group, and tomato represents another group? No one's going to be able to distinguish between those things, right? It's not okay. But anyway, You can also, so if you're going to print in black and white, colors don't really do very much. And so you have a few different line styles. And for whatever reason, this is how Matplotlib has, well, not whatever reason. It's a holdover from MATLAB. So Matplotlib is kind of like MATLAB's graphics adapted for Python. And these are the way you specify things in MATLAB. So you can have a solid line, you can have a dashed line, a dashed dot line, or a dotted line. And I think that's about it. So solid, dashed, dashed dot, and dotted. And you can kind of specify that. And I think that's it for line styles. Oh, I guess you can specify. There's also a way to specify stuff. Oh, but that's a pain. Okay, these are not like densely dash dotted. Is dash dot dotted is not like a common thing, but you can use this tuple to specify the line style, I guess. All right, so you can specify the thing, but these are probably going to be simple enough, right? So 4 different line styles. That's probably a good number of line styles. More than that, I think it's going to get tough. The point of graphics is so that your user can understand them. Okay, the person viewing can understand it. It's not so you can just kind of produce something. All right. The point of creating a data visualization is so that the viewer can understand it. And so you always have to ask, like, is someone going to be able to understand what is being plotted here? Okay, other things you can do. You can change your figure size, okay? So first you would do plt.figure to define the figure. Then you add the content like a scatter plot. You can change properties like the axes and things like that. So here I'm going to just do 100 random values, okay? Going from 0 to 1, 0 to 1, and this is what we have. And we are going to, I'm going to just show you like a few things you can do for altering a scatter plot. So this is all using Matplotlib. My personal preference for data visualizations, I still kind of prefer ggplot in R for data visualization, but you know, sometimes you got to do stuff in Python, and Matplotlib is capable enough, okay? But there's a few things you got to kind of adapt, right? So here I'm going to, you can kind of create an array of colors, right? So, and you can also kind of change the size. So here I'm going to create, here I have 100 dots, and here I have an array with 100 values. And this array of 100 values, I have different colors like green, red, blue, yellow, magenta, stuff like that. And then here I have an array of 100 values for different sizes, and you can use that to kind of change the different size. And so here I'm going to create the same scatter plots using the same data, okay? But I'm going to make the plot bigger, figure size 8, 8, X location and Y location. S is for the size. We're going to change the size to match this vector, Z, and then we're going to change the colors to match this vector, or not vector, array of colors, single letter colors here. The alpha is a transparency thing so that when there's overlap, you can kind of see one under the other. And so here this is the same data, just showing, at least for the X and Y coordinates, showing things. And then I have things mapped to the size of the dot, as well as the color of the dot. And so you can see things like here I got 3 dots in a row, kind of right around 0 and 0.9-ish, okay? And we have those same 3 dots in a row here, except they're just of different sizes and different colors, blue, green, yellow, those 3 dots. In this corner, I kind of have these 3 dots forming a little triangle, and you can see those same 3 dots forming a triangle down here as well. So you have that. You can also change the marker, but unfortunately for the marker, unlike the size and the color, you can't map the marker to a variable. So that's a little unfortunate. These are some of the different marker options that you have. The default is the point, but you can kind of change it to a pixel, circle, triangle down, triangle up, triangle left, triangle right. And you can see these are kind of like, a lot of these things are trying to mimic, like if you had to show triangle facing to the right on the keyboard, you might use like the greater than sign or something, okay? Star for the star marker, and then you have a few other things like diamond and hexagon and stuff like that. And so here it is for stars. Here, I'll show you triangle right, looks like that, and triangle left looks like that. Yeah, this looks like some kind of abstract art now. Circle marker versus dot marker versus pixel marker. Pixels being little squares. And then you got, the pentagon marker and the hexagon marker. What is the pentagon? There's the pentagon. Okay, but anyway, we'll leave it at stars because stars are fun. All right, so you have a whole bunch of different marker things. Okay, you can plot different markers on the same thing. It's just they have to be their own separate series. So here I can do a scatter plot of some x and y values with stars, and then another scatter plot with O's, and then and you can also add a label like group A and group B. And if you have a label on these different series, you can also add a legend. So here we're going to make a figure, create a scatter plot for these two different kind of things, and then we're going to add a legend. And there you go. There's group A and group B, stars and dots. Again, you want to change these things up. You want hexagons and pentagons. Oh no, that's the plus. Sorry. Okay, but that's hard, right? The red and blue I can distinguish, but people don't rarely notice the shape of the plots unless it's especially if it's like hexagons versus pentagons. Okay. You can also create little subplots to make figures and stuff. So with a subplot, so subplots unfortunately are not zero indexed, so it's annoying. But here, if I create I can say I want a subplot with 2 rows and 3 columns, and then plot 1 is the top left, plot 2 is this top middle, plot 3 is top right, and it kind of counts across the rows. Okay, but you can see it's not zero indexed. This is a holdover from MATLAB. MATLAB is not zero indexed. It's like R, and it's 1 indexed. Indexes start at 1, and so unfortunately, this subplot feature kind of has this thing. And so you can say, you know what, in this subplot, I want you to do this thing. And right now, the command for each subplot is just add some text. But if you wanted to add, points or a line or something like that, you can do that as well. Right. Okay, and so here is an example of a subplot. And you can see how tedious working with a subplot can become. But let's see if we can understand what I'm going to try to do here, right? So I have 3 series: sine of x, tangent of x, cosine of x, subplot 2, 2, 1. So that means I'm going to create a 2x2 grid of subplots, and number 1 means for the top left one, I want to plot x and y, and we're going to add the title sine of x. Then we're going to go to subplot 2, 2, 2, which is going to be the top right second one, okay, or top right one, a 2x2 grid, and we're going to plot cosine of x. And then 2 by 2, 2, 3 is, again, 2x2 grid. The third one is going to be lower left. We're going to plot tangent of x. And then 2, 2, 4, 2x2 grid. The fourth one will be the lower right. And we're going to plot sine and cosine together in red and blue. So we do all of this together to kind of create our subplot, and then finally we will call show. And so there we go. Sine of x, top left, cosine of x in the top right, tangent of x down here, and then sine and cosine right there.
Professor?
Yeah.
The other one was like 2, 3, 1, 2, 3, 6.
What about this?
Yeah, so you have to use 2, 3. So 2, 3, why does it work?
So when you call subplot, you can specify how many rows and how many columns you want. So 2, comma 3 will create 2 rows and 3 columns. If you do 2, comma 2, it'll create 2 rows and 2 columns. Or is that not your question, or what?
So in the first one, it creates a plot. It creates like basically 4 plots in a 2 by 2 way.
Yes. So this line right here, plt.subplot 221, it's going to create a kind of a 2 by 2 grid of subplots, and then you say, all right, for the first one, I want which is top left, and it counts. The top left is number 1, and it counts across the row. Yeah. So if I did like 4, comma 4, then I would have 4 by 4 grid, and I would start at 1 in the top left, going all the way to 16 in the lower right. But that's too many, okay? There's another thing called grid spec, okay? Now grid spec is something specific to, I guess, yeah, Matplotlib, and unfortunately this one is 0 indexed, go figure. And so here you can say grid spec 2, comma 3, and that will, so I think that's going to create 3 rows and, wait a second, okay, I gotta check this. No, okay, 2 rows and 3 columns, okay, but you can say, with grid spec, you specify, so yeah, 2, comma 3 will create 2 rows, 3 columns, but you can have like plots span across multiple things, okay? So here, we're going to call subplot grid 0, 0, that's going to be the top left. Okay, and then I can do subplot 0, comma 1, colon 3. So using slicing, it's gonna say I want this region from the the 0, comma 1 to the 0, comma 2. I want this thing to span across that, and then here I can say 1 and then colon 2. So basically, I'm slicing out the grid to span this thing, and then 1, comma 2 will get me this thing. And I can create like a different plot in each of these things, and you can do this. This is, in my opinion, more effort than what it's worth, okay? Just make 4 plots and have them go one right after the other. Unless there's something really like you really want the things to line up in such a way, like for example, you want to have like a bivariate normal distribution, and you want to kind of show how along here in variable x1 it's normally distributed, in variable x2 it's also normally distributed. Like that's like the only time where it's like it's really important to have these different plots line up. That would be really the only time you should bother using a subplot. But if it's just like, oh, I just want to have like 4 plots, just make 4 plots, okay? This is way too much work, okay? And then honestly, we have packages. We'll look at like Seaborn in the future, where we do stuff. Okay, I gotta hurry up here. Let's look at question 2, and the answer key is A. All right. Okay. So other things that Matplotlib does, right? So statistics, histograms, like one of our most important tools. So here I'm just saying, give me some random normal values, and then you do plt.hist. And you give it, basically your array of data. Okay, you give it your array, and then it's going to create a histogram here. This is the default settings for creating a histogram. There are options you can do. You can change the number of bins. I always get this mixed up because when I switch between R uses breaks, and Matplotlib uses bins, and it's so when and it's thrown off like when I code in R as well. Sometimes in R I'm typing in bins and I get error messages, and I type in breaks into Python. It's just one of those things. It's like, so I keep getting these things mixed up. But anyway, so you can specify the bins, you can change your alpha, you can change the color, you can change the edge color, and so now this is what your histogram looks like. There's another style type which doesn't draw the lines in between the bins, but it just kind of outlines the whole thing. So same exact shape of the histogram here, and we have this. This color is called steel blue, whatever. Okay. So we have that. Okay. Here, so one thing that you can also kind of do is this is like keyword argument unpacking. So remember tuple unpacking or we call it scattering, right? So you have your values in a tuple, and then you put a little star when you call a function, and then it scatters those into like multiple arguments for that function. Same kind of thing, but you can kind of pair it with a dictionary. So over here, I want to create over here for the histogram, I specify these options. Histogram type step filled, color steel blue, edge color black, alpha equals 1, bins equal 25. So here I want to do the same kind of thing, but I want to have like the same arguments for all of these things. So I'm going to create 3 different histograms on the same plot. So I'm going to call PLT hist 3 times, and all of them I want the same options. I want step filled, alpha 0.3, I want density, I want 20 bins, edge color to be black, but I'm going to change the color to be navy, color to be purple. X3 is this. And so X1 is centered at 0, standard deviation 0.8. X2 is centered at -2, standard deviation 1. And X3 is centered at 3, standard deviation 2. And so it's going to create kind of the 3 different histograms. And it's going to kind of expand all of these things. This is the same thing as basically just copying all of these arguments and pasting them in here. Okay, and I could do this, and I'll basically get the same thing. Okay, same kind of thing, but let's say I wanted to change something like if I wanted to change the alpha for all of them, okay, I could do that very quickly by just changing it in one location rather than having to copy and paste that change everywhere. So that's the advantage of using something like the keyword expansion there. Okay, here is a multivariate normal histogram. So that I'm going to just use this thing to generate from the multivariate normal. Multivariate normal, you need to have basically x1 and x2 coordinate for the mean, and then you'll have a 2x2 matrix for your covariance, covariance thing. And so here I'm going to generate a whole bunch of values, and you can say I want a 2D histogram, and you'll get something that looks kind of like this, right? And then there's like the more sci-fi looking one where rather than a grid you get hex bins or whatever. I don't know. Okay. You can also create a 2-dimensional array using something called mesh grid. Okay, so here for x I got 0, 1, 2, 3. Y I have -1, 0, 1, and 2, and then I'm going to create a 2-dimensional function that just takes x and y and returns the product of them. You could imagine this function being anything a lot more complicated, but just to kind of show you how mesh grid works, I'm going to say create a mesh grid of x and y, and basically it's going to do the product of y across these and x. So when x is 0, 1, 2, 3, and I multiply it by -1, I get 0, -1, -2, -3. When I multiply it by 0, I get 0, 0, 0. Then I multiply by 1, I get 0, 1, 2, 3, and then I multiply by 2, and I get 0, 2, 4, 6, right? So it's basically creating, I take x along one side, y along the other side, and then those two coordinates kind of create the value where they intersect. And here I'm just using a very simple x times y, but you could use any kind of complicated thing. So you might have like a multivariate probability distribution or something. So here I'm going to do something a little more complicated. -3 to 3, linearly spaced, 101. I'm going to create a mesh grid. So I'm going to basically -3 to -3 across the top, -3 to -3 down the side. And then what I'm going to return is basically the product of two normal distributions. And so here I'm going to get kind of this big, not that huge, but like a 101 by 101 array. And then I'm going to say, hey, make a contour plot. Okay, a contour will draw lines where you have values that are equal to each other. Okay, so the data goes from -3 to +3 in both the x and y, and here it's drawing lines to kind of show these are locations where everything is equal to each other. So all around this circle, the values of z are all equal to each other. Okay. You can also do imshow, which will kind of create like a heat plot, and it shows like all of these values have similar values, and then the different values are shown with different intensities of color. Pandas again has a lot of kind of plot functions built directly in to kind of work with a data frame. So here I'm going to create just kind of a series of just a whole bunch of values, and I'm going to say here I just took some random values. The axis, the index is a date index. Okay, I've got a date index, and you can just kind of say take your series and do series.plot, and it's going to put the index along the x-axis and then the values along the y-axis. So that's just kind of like a built-in function of pandas where it understands that, okay, if you have an index, it's going to put the index along the x-axis and your values along the y-axis. Okay. Similarly, I can do something similar with a data frame. So here I've got a date index along the x-axis. I've got different kind of series, A, B, C, D, different columns here, and all I have to do, okay, so if I have this data frame, I can just say, hey, make a new figure, do dataframe.plot, and it's automatically going to kind of plot the different series here. Okay, it's going to plot the four things. It's going to automatically also produce a legend to go along with this. All right, let me give you your last view quiz answer. If you just have a very simple kind of thing with kind of 4 unique values or something like this, here's a series, A, B, C, D, kind of a categorical. The index is 8 categorical, and I've just got different values. There's a few different plots you can do. One is you can just make a bar plot, and it will create this. So A was -6. So this is a funny looking bar plot because I've gotten both negative and positive values. I think most of our bar plots we're used to seeing only positive values, but this is how you could do a bar plot with both negative and positive values. And again, what it's gonna do anytime you call plot on a pandas object, generally it's gonna put the index along your x-axis because everything in pandas has an index, right? Okay. Here I've just got some random numbers arranged over here. I've got my index are these service sectors, okay, industry sectors. I've got different states. These are just made up numbers here for these different columns. Okay, so here I can say, hey, take this data frame and make a plot. Okay, and so again, it puts the axis, the index along the x-axis. So we're going to get tech, agriculture, manufacturing, service, and other. and then it recognizes we have 4 different kind of columns here, and it just kind of creates each of those as different bar plots. Now, if you want the states along the x-axis, what you have to do is you transpose your data frame so that your index will now be the states, okay? And so now we will get states along the x-axis and things like that, okay? Here, right now the legend is showing up on the inside. If you don't like that, you can change some of the options for the legend to get the legend to show up on the outside, okay? And then you have a few options as far as plotting a bar plot. You can, the default is this kind of side by side, but if you want to like stack them, you can have them stacked as well. And those are some of the things that you can do. Okay, so again, keep in mind, whenever you have a data frame, whenever you have a series, whatever's on the index, that's going to generally show up on the x-axis. Okay, sorry, I'm going a couple minutes over. All right, so here's just a kind of another data frame. Here, the data frame, I just kind of have a column called 1, and then another column where I'm doing kind of random things, and then I can just say, hey, create a plot of a histogram, and so here I've got these numeric columns, and I just say, hey, make a histogram out of the numeric columns, and it can do that as well. And this is showing a little bit of like the central limit theorem in effect here. So if you have one random uniform, it looks like this, and if you have 2 random uniforms added together, it looks like a triangle or a pyramid. And then as you add more and more random uniform values together, you get something that looks more and more like the normal distribution there. Okay, but thanks for sticking around. Sorry for going a few minutes over. We'll wrap it up here today, and we'll see you on Wednesday.